Alright, this is going to be a short video on what we're going to do in lab number 6, or 5 I think, week number 7, lab 5 on I/O devices. So we have 4 different machines here. The first one is going to be all about conveyor control. So we have this little conveyor here, and we're going to demonstrate how we can make this run continuously and in a jog motion, both forward and backwards. So our logic over here, you can see that we have our e-stop and safety gate as part of our safety circuit. So if we push the e-stop, we lose safety and the light comes on. Or if we open up this safety door, same thing. If both of those are okay, we don't have the light, that means our safety is good, and we can actually put this into run mode. So let's look here. We have auto mode or manual mode. So we're going to put this in auto to start with. And if we are in auto, down here you can see we get the red light right now because we are stopped. The green light will actually start us running, and that runs in the forward direction continuously. Like that, so that is continuous running there. If we hit stop button, that will stop us. If we open up safety door, that also stops us. If we hit the e-stop, that would also stop us. Or if we were to suddenly switch us into manual mode, that also stops us. Any of those things will stop us and drop us out of auto mode. Now, if we want to look at the manual mode, I'll put this in manual. And let's actually try running this in manual. So now, if we want to jog forward or jog reverse, in manual we can go forward with this button here. And you'll see whenever I push that button, we actually bump forward a little bit. If I want to jog in reverse, I can do that by using the reverse button. My conveyor actually goes in the opposite direction. And that is how that works. And that is our basic logic for this conveyor control. You could use that for basic conveyor control for any of these conveyor systems that we're going to use. Okay, so that is a basic conveyor. Let's look at our next set of machines over here. We have 2 pushers here. And for this one, we have a set of buttons for each pusher. I'm going to go down to the pusher logic here. The one on the left is first of all, again, we have safety. So either of these safety buttons or the gate will activate our safety circuit. This one on the left here, so we have limit switches that are actually on the pushers. You can't see them, they're not devices we have added, but basically there is a limit switch that indicates the pusher is at the return position or the advanced position. That is what we're using to indicate to turn on our light. And then here you'll see we have an advanced solenoid. So this is a single solenoid motion here on that pusher on the left. So let's watch how that works. So basically, if I push the advanced button, that moves. I'm going to slow this down so we can actually see it move better. So that's the advance. This is return, so you can see how that moves. So you'll see I just push the button once and it goes. So that is that seal circuit in action. So that is breaking the seal. So if that output is off, it goes to the return position. If I push the advance button, we turn that seal circuit on, it will move to the advanced position. Once we get there, we get our limit switch and our light comes on. Let's do this. You'll see here I have no lights. I don't get this light coming on until I actually reach that position. Okay, so that is the single solenoid operation. Let's look at the double solenoid and how that one works. So this one very similar, except there is actually two solenoids for this. So you'll see with this one, I actually have to hold that button down to make it move. If I take my finger off the button, because I have this limit switch in here, I don't actually seal that in until I get all the way there. So I can actually stop this midway because I have the double solenoid. So I can stop that motion part way and do that. So see how I can stop that part way. Now let's look at, so the advantages of the double solenoid over the single solenoid. One, I can jog it to that mid position. The second thing we'll notice here, let's watch this. If I bring these both out, to their advanced position, what happens if I open up this safety door? So let's say I want to go into this cell now, and I open this safety door. Watch what happens here. See how that single solenoid is, that motion is moving right now, even though I've opened the safety door. So that creates an unsafe condition in there. Notice that this one here, I can't actually move right now, because as soon as I break that safety contact, I can't turn on the output. And if I can't turn on an electrical output on the double solenoid, I can't get motion. Whereas the lack of an electrical output on the single solenoid actually creates motion. So the same thing here, if I hit an e-stop, again, I get motion on the single solenoid. So that's why we say we should not use single solenoid motions on very long motions. So just imagine if somebody put their arm in here. You open this door and you get your arm stuck in here. That is a potentially dangerous situation with that solenoid motion there. Okay, so that is the difference between the single and double solenoid motions. Alright, let's go on to the sensor conveyor. So we have start-stop, e-stop circuits here. Let's go here to the sensor conveyor. So now we know we can do a start-stop circuit with e-stops. on a conveyor. This is our basic conveyor that we have. Our basic conveyor that we've got running that same logic. We have running in a lot of different places now for that conveyor logic. And now let's look at some of these sensors on here. First of all, we're going to look over here. Inductive and capacitive proximity sensors. So this first one here is a capacitive sensor. Second one is an inductive sensor. And I've got a stack light on here that's going to light up. The red light here will come on if a part reads on the capacitive part sensor. The yellow light will come on an inductive part sensor. So you can see the sensing range on these. Sensing range not very far. So if we have randomly placed parts, this is not very good for detecting these parts. Okay, the part actually needs to be within range for it to actually detect. So it's really not very suitable for detecting parts that are arriving in a random fashion. If we were to move that over here, that actually works. And then with the box, you can see capacitive sensor will read the box. The inductive sensor will not, because remember, the inductive sensor only reads ferrous materials. So it's only this gray metal part that will actually get read by the inductive sensor. So if we watch here, if I put this up here in slow motion, you'll see this one here. The capacitive sensor will actually read this box. The inductive sensor will not. So we'll get the red light coming on here, but not the yellow light. So capacitive sensor reads. Inductive sensor, it's in the range, but inductive sensor does not read it. So in general, between these two, capacitive sensor is better at part sensing. Inductive sensor not very good at part sensing, but neither of them work very well at all. Let's go over here to the photo eyes. Here we have the diffuse photo eye, so you can see it shooting across there. And here we have the retroreflective. So with the retroreflective, you can see it needs the reflector to operate. So both of these read very accurately. You can see diffuse is the red light, retroreflective is the yellow light, and you can see in our logic here, these read every part that comes by very accurately. The one difference you will notice here, for the retroreflective, it actually gives us a signal whenever there is not a part there. And then the signal goes away when we do have a part there. So we need to use the normally closed version of that sensor, of that contact, in order to use it. So that's what that's indicating there. So these are very good for part sensing. If we go a little bit further down the line here, you'll see that we're using the capacitive and inductive sensors again. In this case here, we actually have some diverters. These position the parts right in front of the sensors every time. And this enables us to better utilize these two sensors, but they're still not very good. So the capacitive is reading pretty much every time now, because we're basically forcing the part into a better position. But this does create a hassle to try to do this. Let's see if this one here reads the inductive. See, the inductive reads that one because that is the ferrous part there. The gray one will be read by the inductive sensor. So that's that going on. Now let's go to this fun thing over here. This is a positioner. So the purpose of this positioner here, this is 2 single solenoid motions, which I'm controlling with these buttons right here. So I have a clamp and a lift. So let's lift first, just to clear all that stuff out of the way. And I'll slow this down a bit and just show how this is supposed to work. So this helps align the parts for us. So you do a clamp and then an unclamp and then a lift. So when this comes in, I'm going to do a clamp, unclamp, and then lift. And what that will do is it will arrange that part in a nice constant position every time. This is what we were doing if we were trying to pick this part up, and we needed to arrange it nicely every time. It doesn't work so well on the boxes, but it does work very well on these parts here, not when they're standing on their edge. You can see here, this one's coming in kind of crooked like that. So this does work very well to straighten that out and then get up out of the way. But what we're trying to illustrate here is look how we're using these switches in here to indicate our machine position. So I have a couple switches here. These are inductive Proc sensors, and this detects the position of our metal clamp. So this one here is on when I'm up. This one here is on when it's down, so the low and the up positions. And then these ones over here detect when it is up and open, and then low and open, this one here. And between these 4 switches, I can use these to determine my 4 different positions, and that's what I'm using to drive these lights over here. So the lights that I'm using on my control panel here that indicate what position I'm in, these are being driven by those combinations of switches. So you can see how those switches are being used to determine what position my machine is in, and that is the most common use for inductive proximity sensors. That is what we typically use them for, is determining what state our machine is in. Okay, so that is inductive proximity sensors. And then the very last thing we're going to look at here is our vision system. So this is our camera right here. This entire red cone here indicates the field of view of the vision system. So anytime a part is in here, we are going to try to detect it with our vision system. And this is set up to detect blue, green, and metal parts. And these 4 bits come back from the vision system, and different combinations of those bits will indicate what we have. So you see there, it locks onto it. It detects that as a metal part. So metal is the yellow light. This one here is going to detect it as a green. That turns on the green light. You can see green part detected. So anytime that part type falls within this field of view, we should get that combination of bits from the vision system coming back to us. This is the blue one here. We should get blue part detected coming on. There we get that. So the vision system can tell the difference between these different types of parts. And that is utilizing the vision system. Alright, so those are all the parts of the machines that we're going to look at and the logic that's being provided. So now what are you actually going to program? So here is the machine you are going to program. So we have 2 conveyors here, and we have a panel. So what I want you to do, make the conveyor run like all the other conveyor systems run. You've got an e-stop, you've got a safety door, you've got a light for safety, you got start stop buttons, auto manual. we should be able to jog that conveyor as well. And then we have a pivot arm here and some buttons to control that pivot arm. And what we want to do is automatically sort green and blue parts. So what we'll do is have one color, if you want to say green, is just going to go straight through and fall off the end. And the other color, let's say blue, is going to get sorted onto the other conveyor. Now what you have to help you along here is you have a bunch of sensors set up for you. So you have a vision system that is configured to tell the difference between different part types. You have some inductive proximity sensors that you can use. There is a good application for those in here. And you have a diffuse photo eye and a retroreflective photo eye and a reflector. So you can place these wherever you think you need to place them. So you can just grab them, move them around, spin them around. Wherever you think you need to place these, place them on this machine to get them to perform that task. Okay? For the code for this, you should be able to just grab chunks of code, copy and paste, and then rename the tags to the tags that you need to use. Look at the lab sheet. It should describe what the tags are called for these particular tags here. And remember, just copy like this and do a Control C or here for copy and then paste. And you can do that to copy and paste logic, and then go in and just change your tag names. So I think for this one we call this Vision Bool 0 is the tag name. Remember, when you do this, you are also going to be required to add in comments on all of your bits and your rungs. So add in instruction comments and rung comments as well. Have a good commented program. Make this function, and that is your task for today. Okay, so that is the task. Good luck with that, and enjoy. Thanks.